Okay, so today we're going to do section 4.1, a review of linear equations in two variables. So if you remember from previous math courses, a system with two variables in it usually used x and y, and that wherever those points intersected, the solution xy, or the point xy, was called the solution, or if they had more than one solution, it was called the solution set. When you solve a system, you're finding out what they have in common, what's in both of their points, or their groups of points that make their lines. So we have multiple ways that we can solve. We can graph, we can substitute, and we can eliminate. All of these do the exact same thing. Some situations lend itself better to a certain manner or a certain method better than others. If on your test it says to use a certain method, you have to use that method. If the homework says to use a method, use that method. Otherwise, you're free to do whatever method works best for you. So in example 1, it says solve by graphing. So when we solve by graphing, we have two options. Option 1, we can solve by solving for y. In other words, you're putting it in slope-intercept form. Or option 2 is find x and y intercepts. Usually when you're in standard form, which both of these are, remember standard form is ax plus by equals c, finding the intercepts really is the easiest way. So just a reminder, x-intercept, you let y equal 0, and y-intercept, you let x equal 0. So I'm going to do the top equation. I have 2x minus y equals negative 3. If I want to find the x-intercept, I let y equal 0. So that gets me 2x equals negative 3. And then you'll divide, so x will equal negative 3 over 2. Negative 3 over 2 is like negative 1.5. It's right there. When I do the y-intercept, I let x equal 0. So I get negative y. Hang on. Y-intercept. I get negative y equals negative 3. I'm going to divide both sides by a negative 1, so y equals 3. And then to the best of your abilities, you'll draw a straight line that connects those. Then we're going to do the exact same thing for the other equation. The other equation was x plus 2y equals negative 4. So for the x-intercept, you let y equal 0. So I'll have x equals negative 4. And for the y-intercept, I'll have x equals 0, so I'll have 2y equals negative 4. You'll divide both sides by 2 and get y equals negative 2. And then again, to the best of your abilities, you can draw this line. Oh, that was not great. Let me try one more time. Struggling. Third time's a charm. So the solution set, or the solution point, is where they intersect right here at negative 2 comma negative 1. And it does say up here in the directions to check our answer. To check our answers. So let's make sure that we always check and make sure we're right. And the easiest way is just to plug the points back in. So if I check, I'm going to plug in my values. So I get 2 times negative 2 minus negative 1 equals negative 3. That's negative 4 plus 1 equals negative 3, and that works out. For the second equation, I'll have -2 plus 2 times -1 equals -4. -2 plus -2 does equal -4. It works out. So we're going to go to the next page, and on the next page, we're going to solve by graphing again. This time, let's use solving for y, putting it in slope-intercept form, and then we're going to match each one of these to the graph that matches the system. So in the first one, I have x minus 2y equals 2. So I'm going to solve for y by subtracting x. -2y equals -x plus 2. And then divide every piece by a -2. Y equals, negative divided by negative is a positive half x. And then 2 divided by -2 makes a -1. So there's one of my lines. My other line is x plus y equals 5. And all I need to do is subtract the x from both sides. So y equals -x plus 5. So I'm going to go down here and find these two. So one of them should have a y-intercept of -1, and the other one should have a y-intercept of 5. And the only graph that has that is this. One of the slopes is positive, one is negative, so the first one is graph 3. And now some important things to note about graph 3. Down here it says intersection at one point, at one point only, exactly one solution. So on the next page is a whole bunch of vocab words, but while we're on this page, I'm going to write them here. We're going to classify them. This is called consistent. Consistent means I have a solution. And this is independent because it's a unique solution. There's only one. So let's go back up and do another one. So if I do x plus 2y equals -4, subtract x from both sides, 2y equals -x minus 4, and then divide everyone by a 2. Y equals -1/2 x minus 2. So there's one of my equations. The other equation is 2x plus 4y equals 8. I'm going to subtract the 2x over. 4y equals -2x plus 8. I'm going to divide everyone by a 4. I get y equals -1/2 x plus 2. So if you notice right here, this has a -1/2 slope and this has a -1/2 slope. And lines that have the same slopes are called parallel. So this must be graph 1. And not only are they parallel, they have different y-intercepts, one positive, one negative. So this one must be graph number 1. So these lines are parallel. So if we go back to our classifying, there's a solution here. There's no solution here, which means they're not consistent. They're inconsistent. No solution. Which hopefully means this last one's going to be graph 2. So let's try and find out. So 2x plus 4y equals 8. This feels familiar because we just did it in part B, but it's okay, we'll do it again. Minus 2x from both sides. 4y is going to equal -2x plus 8. Divide everything by a 4. Y equals -1/2 x plus 2. There's one of my equations. The other equation is x plus 2y equals 4. So subtract x from both sides. 2y equals -x plus 4. Divide everyone by a 2. Y equals negative 1/2 x plus 2. Now this time, if you look at these two, they have the same slopes and they have the same y-intercepts, which means these lines are exactly the same. So this would be graph 2. The lines coincide and there's infinitely many solutions. So there's a solution which makes them consistent, but it's not independent. The solution is not unique because there's lots of solutions, so that makes it dependent. Oops. So when you are asked to classify the solutions of the system, it's either consistent or inconsistent. And then if it's consistent, it can be dependent or independent. On the next page of your notes, what we just explained is listed on the vocab definitions and theorems. So now we're going to skip ahead to example 3. Example 3 now says we're using substitution. So if you think about substituting, like when your teacher's not there, you have a sub and someone's in their place, you're going to plug one equation into the other. So if you use substitution, find the variable that doesn't have a number coefficient outside of 1 or negative 1. So I have 2x minus y equals negative 6. And my goal is to solve for a variable and get that variable all by himself. So I'm going to minus 2x from both sides. Negative y equals negative 2x minus 6. And there's a negative 1 in front of my y. So to get y all by itself, I have to divide by negative 1. So y equals 2x plus 6. Now I'm going to take that and plug it into my other equations. So step 1 was to solve. Step 2 over here is to plug it in. So I have 3x plus 2y. Please note that I used the other equation on purpose. Equals negative 2. And right here you see where it says y. Well, I know what y equals. Y equals 2x plus 6. So 3x plus 2 times some stuff equals negative 2. And that stuff I'm plugging in is 2x plus 6. So we're going to do some algebra. 3x, you're going to distribute the 2, plus 4x plus 12 equals negative 2. These two make us 7x plus 12 equals negative 2. Subtract the 12 to the other side. 7x equals negative 14. Divide by 7, and x equals negative 2. Now that's just half your answer. You have to plug that back in. Take that and go over here and plug it in. Y equals 2 times negative 2 plus 6. Y equals negative 4 plus 6, which equals 2. So my ordered pair as an x comma y is negative 2 comma 2. And as always, we should check our answers. So let's check it. We had 3 times x, which was negative 2, plus 2 times y, which was a 2, equals negative 2. Negative 6 plus 4 equals negative 2. That one works. Now the other equation said 2x, so 2 times negative 2 minus 2 equals negative 6. 2 times negative 2 is negative 4, minus 2 more makes a negative 6. That one works out as well. So on to our last page of notes. So on the last page it says that we're going to use elimination. So here are my rules for elimination. Oops. So we're going to do elimination. Step 1. Pick a letter, a variable. Step 2. Make coefficient same number, opposite signs. So in one equation, it'll have a 4, and the other equation will have a negative 4, but with the letter you picked. And then we can add equations and eliminate. So eliminate means get rid of. So if I want to pick a letter, if it were me, I'd pick Y in this case because one of them is positive and one of them is negative. So I already have the opposite signs going on. So to make 2 and 3 match, I should make them become a 6. So I'm going to multiply this top equation by the 3 that was down here. The whole equation. So that 3 has to go to every piece. So that's going to get me 15x minus 6y equals 36. On the bottom equation, I'm going to multiply the whole equation by this 2 I had up here. So this 2 has to go to everyone. So when I do that, I get 4x plus 6y equals 2. Now we add these equations, and this is exactly why elimination is called elimination, because the the y that we picked eliminates. Negative 6, positive 6 cancel out. So I have 18x equals 38. Divide both sides by the 19. Oops, not 19x. 19. And x will equal 2. Now you have to plug that back into one of your equations. It doesn't matter which one you use. 2 says x, but x is 2 plus 3 times y equals 1. And this 2 right here is what I plugged in right here for the x. So I get 4 plus 3y equals 1. I'm going to minus the 4 over. 3y equals negative 3. Divide by 3. And you will get that y equals negative 1. So my answer is 2, negative 1. And then we have application problems. So Jasmine wants to use milk and orange juice to increase the amount of calcium and vitamin A in her daily diet. An ounce of milk contains 37 milligrams of calcium and 57 micrograms of vitamin A. An ounce of orange juice contains 5 milligrams of calcium and 65 micrograms of vitamin A. How many ounces of milk and orange juice should Jasmine drink each day to provide exactly 500 milligrams of calcium and 120 micrograms of vitamin A? So what they want to know is about calcium and vitamin A. So first we'll do the calcium stuff. So in an ounce of milk, I get 37 milligrams. And in an ounce of orange juice, I get 5 milligrams of calcium. So I'm going to let milk be my x variable. And then if I talk about micrograms of vitamin A, there's 57 micrograms here and 65 micrograms here, which means I'm going to let my orange juice be my y. So now we want to put things together that go together. So if I want to talk about the calcium, it was 37 from the milk, the x, plus another 5 milligrams from the orange juice, the y, and this should total up to be 500. The micrograms of vitamin A were 57 from the milk plus 65 from the orange juice equals 1,200. I think elimination probably is our best bet. Substitution feels like it's going to be a little bit ugly. So I'm going to take this top equation. I'm going to multiply it by a negative 13. That's going to change my y to a negative 65. So when I do that, I'm going to get negative 481x minus 65y equals negative 6,500. Now my green equation, I don't have to change at all. 57x plus 65y equals 1,200. So when I go to do elimination, these two cancel off, and I get that negative 424x is going to equal negative 5,300 divide both sides by the negative 424, and you're going to get x equals 12.5. Now remember, x is my ounces of milk. I'll put milk next to it. To find my orange juice, I need to plug that back in. So 37 times the x, the 12.5, plus 5y equals 500. So this should be 462.5 plus 5y equals 500. Subtract the 462 over and you get 5y equals 37.5, and then divide by 5, and you will get that y is going to equal 7.5. And this is OJ. So my answer, story problems of story answers. I need 12.5 ounces of milk, and I need 7.5 ounces of OJ. There's my answer.